In this video, we're going to learn to use the first derivative test in order to find out where the maximum minimums are at. So let's just say this is our function f of x. Pay attention to the maximum. If you realize a relative maximum means that it's the greatest value within that local region. That's relative. We'll learn more about the absolute maximum later on, which is just as it sounds. It's the greatest in the entire graph. Now, this is not the greatest spot in the entire graph. You can see this keeps going up. But within this area, it's the greatest spot. So how do we determine these? Take a look at this. F is increasing and then it decreases. Right there where it goes from increasing to decreasing, we see a maximum. Now the inverse of that, we have as we're decreasing and then increasing, you have that valley, which is that minimum. So you have this hill. Remember, if you go up the hill and then you go down, right? Compared to going into the valley, we're going down and then up. So it's pretty easy to see that f is increasing and then f is decreasing right here. That you see as a maximum. So let's go ahead and use that in our first derivative test. So we're going to use a straightforward, just as we did in that last section, first derivative test, same exact thing. And we're going to use that same test, same amount of work to determine if there's a relative maximum or minimum. By the way, you got to pay attention to the question. Sometimes it asks at what x value, sometimes it asks for the actual maximum or minimum. So I think for this assignment, it's just going with the x values. It's more like we're going to find the absolute maximum min. That's when we bring in the y value. So let's just go ahead and run it through that first derivative test. So let's start by finding f prime of x. And then we got to factor it. So unfortunately with this one, we're kind of stuck because 3 doesn't factor out. So we're going to do the diamond method. What multiplies to negative 12? So remember, we do 3 times negative 4 and adds to negative 4 would be negative 6 and 2. And we're going to divide both of these factors by the 3. So our first factor is going to be x minus 2, because 6 over 3 simplifies to 2. And then we'll have 3x plus 2 for our other factor. So our zeros, I'm going to go ahead and draw our number line. And our zeros will be negative 2/3 and positive 2. Now it seems painful that we have a fraction. It ends up not that bad. Because remember, we're testing values to the left and to the right. So if we test for x less than negative 2/3 for that value, if we plug it into here, something less than negative 2/3, so like negative 10. Think about negative 10, right? So if you were to plug a negative 10 in, negative 10 minus, that's negative. This one would also be negative. So multiply those to get positive. So it's positive on this interval here. And then let's go ahead and test for x between negative 2/3 and 2. So 0. If you plug in a 0, you get negative and a positive, which is negative. And now let's test a value greater than 2 to the right of 2. So like 3. 3 minus 2 is positive. Plug in the other one, you also get positive times a positive is positive. So this is what's cool. Once you have your first derivative test, I kind of like to draw a picture. My function is increasing, and then it starts to decrease. So remember, this is the first derivative test. So we're testing f prime. F prime is positive, tells us the function's increasing. Right at this point, it decides to start decreasing. So that's a maximum. This one, though, we're decreasing, and then at that point, we start to increase. So that makes this a minimum. So a minimum occurs at x equals 2. You do the same thing for that problem. Now, I'll see if I can include the detailed answer. This one's actually less work. These problems, at how many points? So this one, they don't want to know the actual x values. We're going to find the actual x values, though. but at how many points does the graph of G have a relative minimum? Now realize we're starting with G prime. That's why it's actually less work. So we don't know G. We can't just put this one in Desmos and figure it out. But we know G prime. So G prime of x is x to the fifth times x plus 1 times x minus 1. So I'm going to start with our number line. And I have our zeros are -1, 0, and 1. So where did I get those from? This, your x is 0. If you ever have an x out in the front, it's 0. Here's -1. Here's +1. Really, I just wanted to go over that 0. That's usually where people get a little confused. And so for our first derivative test, so if we test a value to the left of 1, and then we're going to test between -1 and 0, between 0 and 1, and then to the right of 1. So let's go ahead and test it. If we plug something negative in there, like -2, we end up with a negative to the fifth power is negative. Think about that. The power does make a difference. If it was squared, it would become positive, right? Anything squared is positive. Then between -1 and 0, like -0.5 plus 1, that's going to be positive. Then last -1.5, I mean, plus 1 is positive. -0.5 would plus 1 would be positive, actually. So I'm a little bit wrong here. So -1.5, we're -2. Why don't we think of -2? -2 is to the left of this. -2 plus 1 is negative. You need to be careful what I'm doing here. -2 minus 1 is negative. So overall, that's going to be negative because a negative times a negative times a negative is negative. And we're looking for that minimum, right? So from -1 to 0, this is what I'm thinking of 0.5 for because of this. -0.5 to the fifth is negative. Anything negative to the fifth is negative. -0.5 plus 1, though, is positive, and then negative. So this ends up being positive because negative times a positive times a negative is positive. Okay, between 0 and 1, like 0.5. 0.5 to the fifth, that's positive. 0.5 plus 1 is positive. 0.5 minus 1, though, is negative. So that ultimately will be negative. Then last, if you test something greater than 1, like 2, to the fifth would be positive, plus 1 would be positive, and minus 1 would also be positive, so that's going to be positive. So, drawing our graph from decreasing and increasing, that's a minimum. Increasing and then decreasing, that's a maximum. Decreasing then increasing, that's a minimum. So we actually have 2 points. And that's the idea of that one. Now this last one, it's trying to trick you. You see how this factored one was G prime? Be careful, make sure it's labeled the derivative. Because this one's not labeled the derivative. This is talking about the original function f. So f of x equals this. So if we want to take the derivative of this, you can either do the product rule or expand and FOIL it out, which is what I'm going to do. So we'll FOIL it out. So we'll have x minus 2 here. I'll distribute these two first to get x squared minus 6x plus 9. Then we'll distribute the rest of it. So x cubed minus 6x squared plus 9x minus 2x squared plus 12x minus 18. Combine like terms. We're in AP, so I'm not really showing you all the little bit of steps there. So that is f of x. So for f prime of x, it's 3x squared minus 16x plus 21. Just really hoping this would be something that we could just factor out a number to. Just want to double check my work though real quick for that x term there. So x cubed minus 6x squared plus 9x minus 2x squared All right, it seems correct. So let's go ahead and factor it now. 3 times 21 is 63. That does make sense. So negative 9 and negative 7 multiplied at 63 and added negative 16. Then we're going to divide each of those by 3. So our factors will be x minus 3, 3x minus 7. So our zeros will be 3 and 7/3. So 7 divided by 3, 3 goes into 7 2 times, 1 left over, so it would be 7/3, and then 3. So now we got to test them. So if you plug in, I'm just going to plug in a 0. That's negative, and negative is a positive. Now a number between 7/3 and 3, we only have the option of 8/3. But it will have a sign change. 8/3 minus 3 is less than 3, so it'll be negative. And then that's going to actually be positive for this one because it's greater than 7/3. So that'll be negative. And then plug in a 4 and you get positive, positive. So increasing, then decreasing, decreasing, then increasing. This wants to know about what value of x do we have a relative maximum. So that'd be x equal to 7/3. So I'm just going to double check that using Desmos. Then we can kind of see the graph, see if what we're doing is making sense. Let's see if I can even draw a rectangle right now. Bad luck on this one, right? There we go, that's perfect. So our original function's x minus 2, x minus 3 squared. So I'm going to zoom in here. So you can see this is the maximum, which occurs at 2.33. Well, this is 2.33 because 3 goes into 7 2 times with 1 left over, so 2 1/3. Makes sense. And then we have a minimum at 3. Boom, there you go. And you can see the functions increasing, then decreasing, then increasing. So it's pretty cool. We can use calculus to figure out the derivative, just to figure out these things about that function.